Your shoelaces can be a ticking time bomb, threatening to come untied at any moment. Imagine having to stop mid-stride to ready your shoelaces, all because of a small thread. Shoelaces are one of the most essential, yet overlooked components of our daily attire. They seem simple, yet their design holds the key to understanding intricate mathematical patterns. For centuries, shoelaces have been a staple in our wardrobes, serving as a perfect example of a real-world application of mathematics. The seemingly mundane task of tying our shoelaces is actually a complex process that requires precision and pattern recognition. But what makes shoelaces so special? Let's dive into the world of mathematical patterns and explore the fascinating world of shoelace geometry. The first recorded use of shoelaces dates back to ancient civilizations, where people used leather straps to secure their footwear. However, it wasn't until the Industrial Revolution that shoelaces became a ubiquitous part of our daily lives. Today, shoelaces come in various shapes, sizes, and materials, each with its unique mathematical properties. The humble shoelace is a masterclass in geometry, with its twisted threads forming a complex pattern of angles and curves. But have you ever stopped to think about the mathematical principles behind the humble shoelace? It's a tale of symmetry, pattern recognition, and the intricate dance of threads. So, let's start by exploring the fundamental principles of shoelace geometry. The shoelace is essentially a twisted rope, with its threads forming a helical pattern as they wind around each other. This twisted rope is a classic example of a fractal, a mathematical concept that describes self-similar patterns at different scales. Fractals are found throughout nature, from the branching of trees to the flow of rivers. The shoelace is a miniature version of these fractals, with its threads repeating the same pattern over and over. But that's not the strangest part. The shoelace is also a perfect example of a mathematical concept called the golden ratio. The golden ratio is an irrational number approximately equal to 1/618, which has been observed in the natural world for centuries. It's found in the shape of seashells, the arrangement of leaves on stems, and even the structure of DNA. The shoelace, with its twisted threads, is a miniature version of the golden ratio, with its proportions repeating the same pattern. But how does this apply to real-world situations? Let's take a look at some real-world examples. In engineering, the golden ratio is used to design efficient structures, such as bridges and buildings. In fashion, designers use the golden ratio to create aesthetically pleasing patterns and shapes. So, the next time you tie your shoelaces, remember the intricate mathematical patterns at play. Shoelaces are more than just a mundane task. They are a gateway to understanding the beauty of mathematics. And that's not the only surprising thing about shoelaces. Their design also holds the key to understanding complex mathematical concepts. The shoelace is a perfect example of a mathematical concept called knot theory. Knot theory is the study of knots and their properties, which has applications in fields such as physics and computer science. The shoelace, with its twisted threads, is a classic example of a mathematical knot. But what makes this knot so special? Let's take a closer look. The shoelace knot is a type of mathematical knot called a torus knot, which is characterized by its twisted, donut-like shape. Torus knots have been studied extensively in mathematics and have applications in fields such as quantum mechanics and topology. The shoelace, with its torus knot, is a miniature version of these complex mathematical concepts. So, the next time you tie your shoelaces, remember the intricate mathematical patterns at play. Shoelaces are more than just a mundane task. They are a gateway to understanding the beauty of mathematics. And that's not the only surprising thing about shoelaces. Their design also holds the key to understanding complex mathematical concepts. But what does this mean for us? Let's explore the real-world consequences of shoelace geometry. The study of shoelace geometry has led to breakthroughs in fields such as materials science and engineering. New materials and technologies have been developed using the principles of shoelace geometry. The shoelace, with its twisted threads, has inspired a new generation of materials scientists and engineers. So, the next time you tie your shoelaces, remember the real-world impact of shoelace geometry. Shoelaces are more than just a mundane task. They are a gateway to understanding the beauty of mathematics and its applications. In conclusion, the humble shoelace is a masterclass in geometry, with its twisted threads forming a complex pattern of angles and curves. From fractals to the golden ratio, shoelace geometry is a fascinating world that's worth exploring. So, if you found this fascinating, subscribe for more incredible stories like this. Want more mind-blowing facts? Hit subscribe and join our journey of discovery.